In this video, we will use the VBLEND instruction to selectively merge two arrays. The VBLEND instruction has several different forms. We will concentrate on the AVX512 version of the VBLEND instruction. As we can see from the instruction specification, the VBLEND instruction has two source operands. The first source operand, which is called source 1, has to be a ZMM register. The second source operand can either be a ZMM register or it can be a memory operand. Our two source arrays, which we want them to be merged, are going to be supplied as the source operands for the VBLEND instruction. The destination has to be a ZMM register as well. The destination will be updated either by an element of source 1 or by an element of source 2. And the op mask register is used as the element control, which decides whether source 1 or source 2 gets to update the destination. Here we have our two source arrays which are candidates for merging. In order to do a selective merge, we first set up the op mask register K1 with a value of hex 55. We use the kmove instruction in our example to load the op mask register K1 with the value of hex 55. The lower 8 bits of the op mask register are shown here. Once we have set up the op mask register, we use the VBLEND instruction with the two source operands pointing to the two source arrays. Our source 1 operand will be in the ZMM31 register and the source 2 array will be directly loaded from memory. The op mask register K1 is also specified in the instruction to act as the element selector, and the destination register is specified as ZMM31. For each index in the destination array, the corresponding op mask register bit is consulted, and if that bit is a 1, the element for that index is updated by the source 2 array. If the bit is a 0, the element for that index is updated by source 1. As an example, for index 0, the op mask register bit for index 0 is a 1. So the index 0 for the destination will be updated by index 0 of source 2, and we will wind up with a value of 0.0 for index 0 in the destination. For index 1, the op mask bit is a 0, so index 1 of the destination will be updated with the value from index 1 of source 1, which is a 1.1. Similarly, for index 2, since the op mask bit is a 1, the value comes from index 2 of source 2. And this process continues until all the elements of the destination array are updated. The destination register ZMM31 at this point contains the merged array, which is then stored using the vmoveupd instruction to the destination array in memory. Let's head over to the terminal and see these instructions in action. Here in the program, on lines 12 and 13, the source arrays are initialized. On line 14, the destination array is initialized to all zeros to begin with, and the mask variable is initialized to hex 55. In the ASM block on line 19, we first load the K1 op mask register with the mask value using the kmove instruction. We then load into ZMM31 register source 1, which is the first source array. We then execute the VBLEND instruction on line 21. The source 2 of the VBLEND points to the source 2 array. The source 1 of the VBLEND instruction is the ZMM31 register, which contains the source 1 array, and the destination will also be the ZMM31 register. And we also specify the K1 op mask register as the element selector for VBLEND instruction. Once the instruction is done execution, the final result is going to live in the destination register ZMM31. We then use the vMoveUPD instruction on line 22 to store the contents of ZMM31 to the destination array. After the ASM block is done, the program just iterates through the elements of the destination array and displays it. Let's run this program and take a look at the output value. And as we can see here, at the completion of the program, the destination array has the values we expect, which ranges from 0.0 to 7.7. I hope this video was useful in understanding the operation of the VBLEND instruction. I'll see you guys in the next video.